Okay, Algebra 2, first hour. All right, this is our last week. So this week we are going to finish up with something hopefully it's a little familiar to you. We're going to revisit some factoring and also some rational expression work. Okay, so let's just get into it and get going here. All right, we're going to review our factoring this week. And remember, we start off with our factoring with our two, probably the most basic types. And that is our greatest common factor and our difference of squares. Remember, when you factor, and this is what we always ended up forgetting to do, but when we factor, we always need to look for a GCF first. And one thing you need to remember about factoring is like a reverse of distribution. So whenever you see something like 4x minus 20, you got to kind of think in reverse. Imagine there was a set of parentheses here, and what would this problem have looked like to produce this answer? Well, when we look and we see this 4 and this 12, we say, hey, with the 4 and a 12, they have a 4 in common. So there used to be a 4 sitting out in front of this set of parentheses. And if there was a 4 in here, what did we have inside the set of parentheses to give us that 4x minus 12? Well, all we need to do then is, we can do it in our head, is just take each of those pieces and divide by 4. And we would divide by 4 there and just get an x. 12 divided by 4 is 3. So this is our factorization of 4x minus 12. And we can say to ourselves, if we distributed this, we would do 4 times x and get our 4x, and 4 times 3 and get our 12, and there'd be that minus in between. So factoring is like doing distribution in reverse. Okay? Now your GCF that you had here, this 4, sometimes your GCF can be a number like it was on that first one, or in this second example here. What do these two have in common? Well, they both have x's. So sometimes that GCF that goes out front of your parentheses is a variable. And do you remember the trick on what variable we would put out front? Now I don't mean x to the what power? Well, it's always the smallest one. Doesn't matter, it's not necessarily the first one, but it's the smallest x that we have, and that's an x to the 5th. And then if we just think to ourselves, well, what happens when we take that problem that we had and we divide by x to the 5th? Now, just remember what you do with exponents when you divide. You subtract them. So when you do 5 minus 5 there in the front, it's x to the 0, which gives you a 1. And when you do 8 divided by 5, or x to the 8 divided by x to the 5th, and you subtract those, you get a cubed. So it's minus 7x cubed. And there is our factorization. And again, we could check it in our head. We could say x to the 5th times 1. That's our x to the 5th. X to the 5th times a negative 7x cubed. You would add your exponents when you multiply, and that's our minus 7x to the 8th. So hopefully you remember a little bit about that GCF there. Now our difference of squares, remember what this name is telling us. A difference, first off, is a subtraction. So you see we have the subtraction between our terms over here. And then squares, remember what happens when you square numbers, what answers do you see? Well, we know 1 squared is 1, 2 squared is 4, 3 is 9, 4 is 16, 25, and so on. But with variables, remember your variables, when you have to have even exponents on your variables. So when we see this x squared and this 25 here and that minus sign in between, remember that's going to be our clue that it's a difference of squares. Now how do we split this thing apart? Well, we got to be fair. Well, how would we be fair if we split apart an x squared? Well, x and x would be fair. What about when we do 25? It would be 5 and 5, because 5 times 5 is 25. And then to finish it off, remember 1 is a plus and 1 is a minus. So that factors into x plus 5 times x minus 5. So when we're doing difference of squares, we see a lot of numbers that are familiar, like 64, 49. So you already in your head, you should be thinking an 8 and a 7. But then notice your variable. It doesn't always have to be x squared, but it does need to be even, because you have to be fair about it. So with x to the 6th, how can I be fair? Well, x cubed and x cubed. And then with that 64, it'd be 8 and 8. Not 32 and 32. It's 8 times 8. And with our 49, 7 and 7, and one's a plus and one's a minus, and we're done. And it doesn't matter which one you make the plus and which one you make the minus, as long as you have one of each. Okay, now that's kind of the old stuff. Now the new stuff is, but what happens when we put that into a rational expression? And remember, when you hear that word rational, you got to remember there's a fraction involved. So we get a problem that looks like this: x squared minus 81 over x minus 9. Well, if we notice, we ought to recognize that numerator, x squared minus 81. What do we notice? We notice it's got an x squared in it that we can split up x and x. It's got an 81 that we can make 9 times 9. And then one's a plus and one's a minus. So we take that top of that numerator, that x squared minus 81, we bust it up as a difference of squares. And then what's our rule whenever we have a fraction? And we have the same thing on top, like x minus 9, and the same thing on the bottom, x minus 9. We get to cancel those, and we get an answer of x plus 9. Now notice what I did not do. And you cannot do this. You can't say, well, 9 and 81 puts a 9 up there. X and x squared puts an x up. You can't do that, because this is not a 9 down here. It's an x minus 9. And it has, what do you cancel x minus 9s with? Another x minus 9. All right? So on the second one, don't let your brain play a trick on you and see that 100 and that 10 and think that you can just get an answer of 10 out of that. Or see these x squareds and think you can cancel those x squareds off of there. You cannot do that. You have to look at it and say, what can I do to this numerator, x squared minus 100? Well, I can break it up x and x, and 10 times 10 is 100, and I have plus and minus in there. It's a difference of squares. What can I do with x squared minus 10x? Well, they both have x's, so let's take an x out of there. And what happens when I take an x away from an x squared? I have an x. Take an x away from minus 10x, I have minus 10. Then all of a sudden, you get to cancel the x minus 10s. And our final answer here would be x plus 10 over x. Now, am I allowed to cancel those two x's? No, because this one is not an x. It's an x plus 10. Now, what's the only thing I can cancel an x plus 10 with? Another x plus 10 in the denominator. And we didn't have that. So we got to know when to stop. We stop right there. Okay. So that's it for today. Now, your homework. Here it is. I put it in the video. You can copy it down out of the video if you want, or I will also post the homework on the like normal, and you can print it out if you'd like to do that. Okay? So we will see you tomorrow.